Hello and welcome back to Eddie Speak Shack, and today what we're looking at is Decision Theory Part 2. Now this does follow on from Decision Theory Part 1, so do have a look at that one first, then we'll get into this one, and then we'll have a look at Decision Theory Part 3 straight afterwards. Now what I'm looking at within this section is we're just specifically looking at risk. Now remember, when we have risk, we know what all of the outcomes will be with a level of certainty, so we know what all the outcomes are, and we can assign a percentage chance to these different outcomes as well. And what this now means is we can take those percentage chances and then we can multiply them by the outcomes of those different percentage chances, and this will now give me an expected value. And that's what this session is all about, trying to calculate an expected value. So let's get into a couple of examples, and what we're going to do is as we go through these examples, I'm going to crunch some numbers and then we're going to show you some of the issues with the numbers that we've crunched. So Eddie has the potential to invest $10,000 into a new investment, and this new investment is going to generate a level of returns, and we're not exactly sure what the level of returns are going to be, but we know that it's going to be potentially be good or normal or potentially poor. If it's good, we get a $20,000 return on our $10,000 investment, 30% chance. Normal, $15,000 return, 40% chance. Poor, $5,000 return, 30% chance. So what I can now do is I can calculate an expected value amount for these different amounts. So I'll take the 30%, multiply it by 20,000, 40% by 15,000, 30% by 5,000, and then add them all up together. So this is what we've done. So we've got the different percentage chances multiplied by the outcomes, and then we add them all together, and that now gives me an expected return of $13,500. So for my investment of $10,000, this looks like it should be a great investment because it gives me an overall net profit figure of $3,500. Brilliant. Now, the good and bad things about this is, first and foremost, it's really quick and easy to calculate. Just crunch the numbers, come up with a figure at the end. If it's positive, then we say yes. This figure has completely ignored the time value of money because I don't know when these returns will actually appear. It's also completely ignored my appetite to risk, and we're going to look at appetite to risk again at the very, very end of this session. So I'm not going to go into that here, but we will go into it again a little bit later on. The other issue I've got here is this $13,500 return is never, ever, ever going to happen. So I'm going to have a return of 20,000, 15,000 or 5,000. I'm never going to get 13,500. So that figure of 3,500 is completely rubbish. It is not a figure I will ever actually create. So that's never a figure I will actually create. So if I'm using this for longer term planning purposes, I know with 100% certainty that that $3,500 is wrong. All right, hang on a minute. That means that future planning can be a real problem for me. Yes, it can. The other issues we've got with this type of expected value come about because of the skew of the percentage chances and then the potential returns. Now, what I've done here is we've got the potential to invest $10,000 into an investment, same as before. Now what happens is we have good and normal and poor returns, but now the figures are slightly different and the percentage chances are slightly different. You have a 20% chance of getting a good return, 40% of normal, and then 40% of a poor return. The normal return gives me $9,000. The poor return gives me $5,000. And now what happens when I crunch my numbers through to work out my expected value, I come up with 20% multiplied by that 30,000, 40% by the 9,000, 40% by the 5,000. And that now means that my total expected return is going to be 11,600. Deduct my initial investment of 10,000. Happy days, I still make a profit. However, I've got, of those three different potential outcomes, I get a positive return if I have a good return of $30,000. If I look at the normal and the poor return, I make a loss. So that now means I've got an 80% chance of making a loss, only a 20% chance of making a profit. And that 80% chance of making a loss is something I would now need to take into account. So the expected values are a useful first step, but you then need to start analyzing the way that you've calculated your expected values because they're never going to be perfect. Ever, ever, ever. There's always an issue with them. And say at the beginning of this session, at the beginning of the first example, we said there was a problem with risk appetites. We do have other models which will allow us to look at risk appetites, and that's going to be Decision Theory Part 3. So we're going to look at Maximax, Maximin, and then Minimax. And we've got a nice big chunky example which will illustrate exactly how that works. Now, hopefully that's made sense to everybody. Remember, you can go back over these things as many times as you want to make sure you're happy with the numbers and be very, very happy with the critique, the criticisms of the way these numbers work are just as important as actually crunching the numbers. So understanding why these are not the best numbers in the world, but they're still useful, is really, really crucial to me. Thank you very much for your time and attention, boys and girls. I'll see you all bright-eyed and bushy-tailed on part 3 very soon.